So good morning students. We are going to start your another unit for you, non-linear kinetics. With this, let us discuss about what is this linear and non-linear. With this, in different cases we will see when one single dose is given to a particular person of a similar drug, then it will follow the same absorption, distribution and elimination patterns, and also it's completely dose dependent. That means the concentration, it depends upon the concentration of a dose. That means how much amount of drug will be in the blood circulation, what will be the plasma drug concentration, that depends upon the dose. So that's why it will follow the first order kinetics. And also when we go for a graph, generally if we go for a semi-log plot, then we'll see when we'll take log c versus time, we'll get a linear curve, a single line will get, and whenever we'll take the same dose of the same drug, all the things, all the rate constant, all the graph will get are superimposable. That means both are similar, superimposable. That means same pattern we will see. And with this type of phenomena we are calling as the principle of superposition. The principle of superposition, and these are all come under linear kinetics. We can call these are linear kinetics. But sometimes we will not get similar ways, similar patterns, and this type of phenomena we are calling as non-linearity, and this kinetics also we can call as non-linear kinetics. So with this, let us discuss about what are the causes of non-linearity. So the causes may be of different types. It may be drug absorption, drug distribution, drug metabolism and drug excretion. So let us discuss about the first one, drug absorption. What are the causes? The first one, if absorption is solubility or dissolution rate limited. If absorption is solubility and dissolution rate limited, then we will see non-linearity. So what will happen at higher doses? It will saturate. It will saturate the solution because there is a solubility problem of the dosage form, and once the saturation attained, it won't increase, it won't absorb, or it will not reach the systemic circulation. So that's why whatever the doses, if it is dissolution rate limited, then it will not attain the required plasma drug concentration. So that's why we'll see non-linearity, although we are giving higher dose, but still we cannot get the required peak plasma concentration. So second one, carrier mediated transport. If it is carrier mediated transport, for example riboflavin, ascorbic acid, cyanocobalamin, this type of vitamins, when you are giving, they are absorbed by carrier mediated transport, and they depended on carrier transport system, dependent on carriers. Once the carriers are saturated, they will not able to go to the systemic circulation, they won't be absorbed. So that's why we will see the non-linearity. Next one, gut wall or hepatic metabolism. So many drugs there, like propanolol, hydralazine, verapamil. So these are pre-systemic metabolism will occur. These drugs will get pre-systemic metabolism. So that's why we will see the non-linearity. Now coming to the drug distribution, the first one, saturation of the binding sites of the plasma protein. Saturation of the binding sites of plasma protein. So there are different types of binding sites. Already I told you in the distribution, different types of binding sites there in the plasma, different proteins there in which the drugs are binding, like your albumin, globulin, different types of proteins there. So that's why once the saturation will occur, example phenyl, butazone and naproxen, these are having the particular number of limited number of binding sites. Once they are binded with that particular binding site, further it will not bind till it is not distributed. So that's why we can tell saturation of binding sites of the protein. The next one, saturation of tissue binding sites. So many drugs they are like thiopentol, fentanyl. So these are having these will occur saturation at the tissue binding sites. So that's why we will see non-linearity. Next one, drug metabolism. So drug metabolism also, due to drug metabolism also we can see non-linearity. Like your first one, capacity limited metabolism. So capacity limited metabolism means due to enzymes, different types of cofactor saturations like phenytoin, alcohol, theophylline. So these are not observed due to enzymes. Then your enzyme induction. So this is also known as auto induction. So due to this enzyme induction, so many drugs, if we'll take regularly, they won't work. They will be metabolized. Whenever we'll give administering the drug, they will be metabolized before reaching the system circulation. So that is known as auto induction or enzyme induction. Example of that drug is carbamazepine. If we will give repeatedly, then we will not see any type of peak plasma concentration, and there is a decrease in therapeutic effect also. Then your drug excretion. So drug excretion also causes non-linearity like active tubular secretion. If active tubular secretion will occur, so many drugs like penicillin G, active tubular secretion means already you know it is also a carrier mediated transport. So that's why if active tubular secretion will occur, then it depends upon carriers, and carriers are limited numbers. If it is saturated, it will not be excreted, and that will affect your uh, plasma concentration, all the patterns it will affect. So that's why we will see the non-linearity. Like that, active tubular reabsorption also, so many water soluble vitamins, glucose, uh, we can see after saturation of carrier systems, if carrier system will be saturated, we will see an increase in renal clearance of this type of substances. That means drugs will not be reabsorbed, it will be excreted. So this will causes non-linearity, and in which we can see the non-linear kinetics. So in the next class we will discuss about another chapter for you in this non-linear kinetics. Mixed order kinetics we will discuss like Michael-Menten equation, and we will complete this unit for you. Thank you.